How can we boil down these complex concepts to a few bullet points? Well, if a reaction starts with an alkene and you get whatever product you're going to get, then that reaction is an addition reaction. If a reaction starts with whatsoever it is starting with and it ends up with an alkene, then that reaction is an elimination reaction. And if our first condition is not met and our second condition is not met, then that reaction is a substitution reaction. What am I even saying? Let me show you what I'm talking about by answering this question. Let's look at 4.1. Consider reaction A and write down the type of reaction that takes place. So reaction A is right here. So let me go through my conditions and see which one is met. Do we start with an alkene? No, we don't. We start with a secondary alcohol. Do we end up with an alkene? Yes, we do. We have propene as our product, right? So we know fully well that from that only, our reaction is an elimination reaction. Our second condition is met. So the answer to 4.1 is elimination. It's elimination. Just because we know that if a reaction ends with an alkene, it's elimination. If it starts with alkene, it's addition. And then if none of that is correct, then it is a substitution reaction. Let's do 4.2 and 4.2.1. Reaction B represents a hydration reaction. Let's look at B. At B, we're starting with propene and we end up with a secondary alcohol. And then we are told that that reaction is a hydration reaction. Right, and then now what we are asked to do is to define hydration reaction. It is the addition of water to a compound. That's it. That's the definition. It's the addition of water to a compound. That's what we mean when you talk about a hydration reaction. We add in H2O to a compound. And the follow-up question, 4.2.2, write down the name or formula of the catalyst used for this reaction. So a catalyst you can use for a hydration reaction is H2SO4. So we can use sulfuric acid as a catalyst for a hydration reaction. Let's look at 4.3 and 4.3.1. During reaction C, a specific rule is followed to determine the major product when HBr is added. Let's look at reaction C. So for reaction C, we're starting with propene and we end up with 2-bromopropene. So let's go back to our conditions. Do we start with an alkene? Yes, we do. So we know that reaction C is supposed to be an addition reaction. Well, the answer to 4.3.1 was actually very difficult to find. But if you visit the CAPS document and other relevant resources, you'll find out that for hydrohalogenation, our addition reaction in this case, we need no water because alkenes cannot react with pure water. And then apart from needing no water, we need a concentrated strong acid. So we need a concentrated strong acid for this reaction that we have in 4.3.1. It is an addition reaction, namely hydrohalogenation. We're adding a hydrogen and a halogen. 4.3.2, use structural formula and write down the balance equation for this reaction. So propene plus HBr. Let's go ahead and do that. So we're going to have 1, 2, 3 carbons, right? So 1, 2. Now we just need to add our hydrogens, and we're supposed to have something like that, plus HBr to give us something. If you look back to the equation statement, it says that during reaction C, a specific rule is followed to determine the major product when HBr is added. So now you actually have to know that rule in order to answer this question. Well, to some extent, we know that this double bond is going to break and either one between H and Br is going to come to the second carbon, and then the other is going to come to the first carbon. So do we get Br on the second carbon, or do we get Br on the first carbon? You need to know where to place that Br, because if you place it at the wrong location, then you lose a mark. But there's a rule for that. There's a law for that. Markovnikov's rule. So basically what it is saying is that the hydrogen is going to go where there's a lot of hydrogens, and then the halogen is going to go to the other spot. So if you look at this carbon here, it has 2 hydrogens, and then the carbon in the middle has 1 hydrogen. So the hydrogen will tend to go to the carbon with a lot of hydrogens already. So that Br, it will usually go to the middle, because that's where we have the least number of hydrogen. So our product is gonna look like this. Br is gonna come to the carbon in the middle, and the hydrogen is gonna come to the first carbon. And then now it's just a matter of filling out our hydrogens. So this is our major product according to Markovnikov's rule. And then Br being on the first carbon and H being on the second carbon is our minor product. This is our major product. Yeah, usually when this reaction occurs, this is the product, right? 4.1. Identify the type of reaction taking place at, so let's go to reaction D. Reaction D. Yeah, this one is going to be easy because we know our conditions. Do we start with an alkene? No. Do we end with an alkene? No. So we know that it is substitution. It is substitution. There isn't a lot to think about there. And then 4.2, which reaction are we interested in? We are interested in reaction F. In reaction F, do we start with an alkene? The answer is no. Do we end with an alkene? The answer is still no. So again, that is a substitution reaction. That is a substitution reaction. It cannot be otherwise. And then 4.5.1. Reaction E is a hydrogenation reaction. Let's look at reaction E real quick. We're starting with propene and we're ending up with propane. So it is indeed a hydrogenation, right? And then what does the equation say? Write down the 2 reaction conditions for this reaction. 2 reaction conditions for hydrogenation. So we need heat, and another thing we need is a catalyst. We need a catalyst. Yeah, which catalyst in this case? We need palladium, platinum, nickel, and so on. Right. And then 4.5.2, name one use of hydrogenation in the food industry. Well, I will leave that one to you.